In this video we'll take a look at problem number 19 from out of section 2.2, and problem number 19 is a type of problem that we have looked at together in class. We're starting with the graph of a function. So this is f of x right here, the directions tell us that, and what we want to do with this function f of x is sketch a graph of its derivative. So over here I'm going to attempt to sketch a graph of f prime of x. And keep in mind that values of f prime of x represent the slopes of the tangent line and what we have graphed over here. So I like to usually look at my function and try to find the places where I have horizontal tangent lines. And I see this location right here where I kind of bottom out and change directions. That's a place where I'd have a horizontal tangent line, or a slope of 0 for a tangent line. And I'm just going to put a little bit of a scaling on the axes here. I'm going to put this as the x value of 1. And I'm only doing that so that whenever I go to the graph of my derivative at 1, I make sure that the graph of my derivative that I'm about to sketch has a value of 0. The slope of this tangent line would be 0. I need my derivative to have a value of 0 at the x coordinate of 1. Now, it doesn't really seem like there are any other places on the graph of this function where the slope of the tangent line would be 0, because if you put your pen or pencil up against the curve, you have pretty steep negative slopes, more level, more level, more level, more level as you're riding across. Then they get steeper, 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 but then they quickly get more level, more level, more level, completely level. And then on the other side of the x coordinate of 1, you have small positive slope to a steeper and steeper and steeper positive slope as you let your pen or pencil mimic the tangent line along that curve. So we have negative slopes over here, steep negatives, more level negatives, slightly steeper negatives, and then more level negatives again. And then over here we just went from a small positive slope to a steep positive slope. So I need to make sure that my derivative that I sketch over here has negative values everywhere I had those negatively sloped tangent lines. I want very big negative values when I'm at next value over here. So I'm going to start on this portion of the graph with a pretty big negative value, right? So there's a pretty big negative value on the graph of f prime. And I'm going to let that negative value begin to get smaller, right? So my negative value is going to begin to come up and get closer to the x-axis, get closer to 0. So the slope of the tangent line at this x value right here, if I use the graph of the derivative to determine this, maybe this y value at, say, the x value of -3 is something like -3. On the graph of the function at -3, the slope of this tangent line would then have to be -3. But the slope of the tangent line is beginning to level off as we let x get closer to 0. So as x gets closer to 0, the slope of the tangent line is leveling off, leveling off, leveling off. But at 0, I think you'd probably agree that it seems like we have a tiny negative slope on this graph for the tangent line at 0. So it doesn't completely level off. So when I get to 0, I can't have my derivative value be hitting 0 or becoming positive, because I never have a 0 tangent line for a slope of tangent line being 0 here, or the slope of the tangent line being positive. And then it gets a little bit more negative as we get closer to 1. Right? But then the slope of the tangent line begins to level off again, and by the time we get to 1, the slope of the tangent line is 0. And then on the other side of this point, the slope of the tangent line just has to get more and more positive, right? Starts off as a small positive, and then it gets to be a steeper and steeper and steeper positive. So that's how you can sketch the graph of a derivative if you're starting with the graph of a function.